Hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 31 of the October Daily Leetcode Challenge. So first of all, congratulations to all of you for all the hard work that we have done for this month's October Daily Leetcode Challenge. Okay, and happy Diwali to all of you and your family. And coming to today's question, it's again a hard question. There are so many things to learn here, but yeah, I agree that it's not something that is very relevant in case if you're expecting, if you're preparing for something for interviews or online assessments. I think that this is not something that you will get much to learn from, because here there are some tricks involved. Okay, other than that, the question is fairly okay, but yeah, there are certain tricks involved. Only if you use those tricks you will be able to get the answers. So in today's question I will be showing you one approach which fails. Okay, that is for which you will face the time limit exceeded error. Okay, I will modify this the same solution and I'll show you a solution which works. Okay, which is optimized and which gets accepted. Okay, as you see, I've already solved this solution. Okay, so I will show you both approaches and I will show you why this particular approach fails and how to make a small change here so that it gets accepted. Okay, that is how to make it optimized with just simple change. We'll discuss the same today, but yeah, this is on a harder side. Okay, this question is definitely on a harder side. If you're a beginner, maybe you can just try to get something out of it, but yeah, don't be hurt that if you are not able to solve this on your own in the first go. Okay, it's not something where you can solve it on the first go. Okay, there is something to learn from it, that's it. You don't have to solve it on your own. Okay, yeah, for these kind of questions. Okay, because there are tricks involved. Without the tricks you will not be able to solve this kind of questions. Okay, so the question is 2463. Okay, minimum total distance traveled. Okay, if you see here, there are so many things given. The first array is the robots array. Okay, these are positions basically. So the idea here is the robots are present in 0, 4, and 6 positions. If you can see the image. Okay, and the other is the factory array. Okay, factory tells me basically which position these factories are present. For example, 2 and 6 in this case, and what are their maximum limits. Okay, that is this particular factory can process two robots, and this factory can process two robots. Okay, that is what they're trying to tell. Okay? Now let us see the question. There are some robots and factories on the x-axis. Okay, you are given an integer array robot where robot of I is the position of the ith robot, where I have told you the same. Okay, also you are given a 2D array factory where factor of j is equal to the position and its limit. Okay, I told you the same. Okay, indicates that position of j is the position of the jth factory, and jth factory can repair at most limit j robots. Okay, the position of each robots are unique, and the position of each factory are also unique. Note that robot can be in the same position as that of the factory initially. Okay, all the robots are initially broken. They keep moving in one direction. The direction could be negative or positive direction of the x-axis. Okay, when a robot reaches a factory that did not reach its limit, the factory repairs the robot and stops moving. Okay, this is important. See, from here the important part of the question starts. Okay, so from here you will have to pay a lot of attention. Okay, whenever a robot reaches a factory or it crosses a factory whose limit is not reached, then it will be repaired. Okay, at any moment you can see, you can set the initial direction of the movement. That is, see, the idea here is you will have to decide which direction the robot will move. Okay, whether, see, based on the nearest factory you will have to decide whether this particular robot should move to the right or towards the left. Okay, that you have to decide. That's what they're trying to say. Okay, that is what they're trying to say it here. Okay, return the minimum total distance traveled by all the robots. Okay, the test case are generated such that all the robots can be repaired. Okay, the idea is the robots will have to travel to one of their factories to get themselves repaired. Okay, all the test cases are designed in such a way that all the robots are able to reach a particular factory and get themselves repaired. Okay, that is the basic idea. Yeah, that is what we have written, the total distance travel, the minimum total distance traveled by all the robots. Okay, and there are some notes here. All okay, robots. Okay, these things are not important because, see, the speed expect, they're just trying to confuse you. It's not needed. Okay, you don't have to consider all these things. Okay, if two robots move in the same direction, they will never collide. Okay, if two robots move in opposite direction, okay, these two things means the same. Okay, these two things means the same. The robots are never going to collide with each other. Okay, if a robot passes a factory that reaches its limit, it will simply cross it. Okay, if the robot moved from, that is, yeah, they are trying to tell is that you will always have to take the absolute, that is, even if they travel left or right. Okay, you still have to take the absolute difference in the position. That is, for example, even if they are moving from the negatives. Okay, for example, if you see here the positions are getting negative here, so still you have to take the difference such a way that the distance travel remains always positive. Okay, it cannot be negative. That is what they're trying to say. They're asking you to take the mod. Okay, so that was all for this question. You have to return the minimum total distance covered. Okay, so which robot will go to which factory, that you have to decide, but ultimately you have to configure in such a way that you get the minimum distance traveled by them. Okay, so what we are going to do, this particular solution will face the time limit exceeded error. Okay, we'll see how to optimize it to get the answer. First of all, see the solution here. We have to just make 2 to 3 lines of modification in this to get the answer. Okay, so I'm first of all taking the length. Okay, robo length. Okay, it is going to the length of the robot array. Okay, similarly, I'm first of all I'm sorting it, then I'm sorting the factory. Okay, based on the position of the factory. Okay, remember x of 0, what is this? See, I'm taking a lambda function, I'm passing the input x, and for that I'm taking x of 0 to sort the array. So what I'm trying to say is, based on the position on the which the factor is present, I'm sorting it. Okay, see here very carefully. This thing is very important. Okay, the first parameter, that is zeroth parameter, is the position. The first parameter is the limit. Okay, so I'm taking the zeroth parameter here. Okay, as simple as that. Then I'm declaring a array called all factory. What I'm doing it here, see, I'm simply expanding the factories. That is, if a location has, for example, see here, yeah, this particular factory can process two robots and it's presented position 2. So what I'm going to do is, I am going to place two factories there. Okay, the idea here is, see, instead of having them in a 2D array, I'm going to flatten them and making them as a 1D array. Okay, let me quickly show you how this works. So basically what I'm trying to say is, see, I am talking about this. Okay, I'm talking about this particular code. So what is this flattening mean? Okay, sorry, yeah, I'm talking about this particular code. Okay, what is this flattening being done is, see here. Okay, this is the factory given to me, right? The 2D array. I'm trying to make it 1D. So what I'm doing, see, this particular factory is parallel position 2, and it can process two robots. So instead of keeping it like this, I am, expanding it. Okay, so I am keeping two factories now at position 2. Okay, that is the basic idea. Okay, because it has a limit of 2, so instead of keeping it as a single unit, I'm making it as a 2 unit. Okay, similarly, this particular factory as a position 6 can process two robots. I'm making 2 units of it. Okay, so that each unit can process one. So that is just, I'm flattening the array. Okay, and I'm calling it as a all factory array. Okay, next I'm declaring a function. This particular function is going to do everything for me. Okay, and this is the function call. So what I'm going to do, see here, this is going to be the robo index, this is going to be the factory index. Okay, this r and f are going to be the robot and the factory array. Okay, and this is going to be the distance traveled. Okay, you maybe, you can even remove that, this is not needed, because the earlier robot that I coded, I was using this, but yeah, currently it is not of any use. This can be removed as well. Okay, so what I'm doing here is, initially I'm starting from 0 comma 0. See, one important thing that I want to tell you in this question is that, see, always, see, after sorting, see, I'm sorting the array, right? I'm sorting the robot and the factory. So the assumption which this question makes is that you will always have to, tie, that is, the first robot should always be tied to the first factory. Okay, so the idea here is, even if you don't select the first factory, still whichever factory you select first, that you have to tie with your first robot only. Okay, the second robot should not be tied to the first robot. That is what they are trying to explain here. Okay, that is the basic assumption with which the solution is written. Okay, you can go to the editorial and learn about it more. They have given some, samples here. Maybe you can go through that and try to understand this part. But yeah, the assumption that they are trying to teach here is the same. Okay, see this part, you'll have to click here, and then they will give you some scenarios basically. Okay, they'll give you certain scenarios, you can go through them. Okay, you can go through all of the scenarios, all the scenarios that they have given, but the idea here is the same, that always the first robot should be tried to the first factory. Okay, see, that is, let us say there is five factories and there are two robots. So after you process the first robot, only then you should process the second robot. That is what their idea is. Okay, that is, say the first robot, then let's say there are five factories. Okay, the first robot started, the first robot went to the fourth factory, only then the second robot should go to the fifth factory. So always the first robot should be focused towards. Okay, and it should be tied to the first element onwards on the factory. That is what they're trying to say. Okay, you can just go through the this editorial. That's why I'm saying this question is slightly tricky. Unless you know these things, you will not be able to solve this. Okay, the way they have coded it. Okay, so what I'm going to do, yeah, this is the robo index. Initially, to see, both of them are going to be 0. That is, always the first robot should be tried to be matched to the first factory. Okay, that's what I am doing it here. Okay, R and F are simply the robo and the factory arrays. Okay, they are just the arrays, and this is the total distance traveled. Okay, till now. Okay, so what I'm doing, see, these are the edge cases. Okay, these are the edge cases. If my robo length exceeds the actual length of the array, simply return 0. If no factories are remaining, okay, that is, all factories are over. In that case, you have to return infinite value. That is, current assignment is not possible. Okay, the distance that you have to travel now is infinite distance. Okay, that's what they're trying to say. Remember, if I do not, that is, if this condition is not true, that means the robots are remaining to be, robots are remaining. Okay, that, yeah, they are yet to be like, yeah. Okay, just a second. Yeah, the robots are still broken. Okay, there are robots remaining which are, pending for repair, but you don't have a factory left. That is what this condition is. This condition will be true when robots are left, but you don't have a factory remaining. Okay, in that case, you will have to return infinite, because the distance of it all in that case will become infinite. Okay, now see, there can be two cases here. Okay, either you can assign, that is, I'm at this particular robot, right, and I'm in this particular factory now, okay, and these two I'm considering, okay. Either you can assign this robot to this factory, okay. Either you can do that or you can skip that, okay. That is, I don't want my robot to be repaired at this particular factory, okay. I will go to the next factory. That is the basic idea. Either you can repair them in the same factory, or I don't want my robot to be repaired here, I will go to the next factory. That is the basic idea here, okay. So what you have to do, let us say I decide to repair my robot in the same factory. So what I have to do, I will have to make the robot travel towards the factory. So what I have to do, R of robo index minus F of factory index. Okay. So what is R? R is basically the robot all array. What is F? F is basically the factory array. Okay. All factory array and the robot array. Okay. So I'm subtracting them to get the absolute length. This is going to be the distance that my robot will have to travel to get itself repaired. Okay. So again, once it is repaired, I will be again calling this function recursively. Okay. I am again going to call this function recursively. This time what I'm going to do, see, my robot is repaired now, right? So I will be going to the next robot for repair. Okay. So I'm going to do robot index plus one. Okay. I'm going to robot index plus one. Since I've used this factory is of no use now. I have to go to the next factory now. Okay. Same. R and F will remain the same. Okay. And the distance travel. Okay. The distance travel will be the previous distance travel plus the distance covered in this particular case. Okay. This you have to add it here. This together will be sent as a single parameter. Okay. As simple as that. Okay. Whatever value is written, I am calling it as K1. Okay. This is the case when I am, currently yeah, getting my robot repaired. Okay. Other cases, I don't want my robot to be repaired at this particular factory. What I have to do, the robot index will remain the same, but the factory index will be increased by one. Okay. Rest all remains the same. R and F will be as it is, and distance travel, since I am not repairing my robot, so the robot will not travel any distance in this case. Okay. So distance travel will remain as it is only. Whatever was supplied to me, same time I'm going to pass it in the next function call. Okay. So whatever value is written, I'm calling it as a K2. Okay. So you'll have to take minimum. What is the minimum? See, what is K1? K1 is the return value of this particular function call. To this, you will have to add distance covered. Okay. So see, what is basically K1? K1 refers to how much distance you will have to travel for getting the other robots, repaired. That is going to be referred to as K1. Okay. And for the repairing the current robot, you'll have to travel this particular distance. So you have to add them together, and you have to see whether this particular thing is maximum or this K2 thing is maximum. Okay. K2 basically means I'm not, repairing my robot in the current factory. I'm trying to go to the next factory. Okay. As simple as that. So this will be because this particular function will be, the function call will happen, and the return value will be examined. Okay. Whichever is the return value, you have to return from here. Okay. As simple as that. So this is the basic idea in this particular question. And finally, I am making the original function call here. And initially, I'm starting with 0. That is the first robot and the first factory. And I'm passing the robot array and the all factory array. And the total distance initially, that is the distance travel initially is 0. Okay. I'm passing that. So if I can run this and show you, okay, this is how it looks basically. Yeah, this is how it looks. This is getting accepted. But the thing here is time limit exceeded error will come. Okay. Why is that so? See, for each robot face index, I'm calculating everything. Okay, I'm doing all the function calls. But the idea here is, if you trace all the index, that is, if you give a print statement here, okay, if you give a print statement here, like how many prints you are making, these two things, if you try to print it, basically, okay, I will send you this. You will see that some of them are getting repeated basically. Okay, if I can run this and show you, see, you will see that certain things are getting repeated basically. Okay, this was a smaller case, but in larger cases basically you will get to know that certain things are getting repeated. Okay, for example, see here, 1 and 2. Okay, 1 and 2 is getting repeated here. Okay, so even though they are repeated, you are again and again calculating the same answers again and again. Okay, though it is not a good practice to do so. Okay, so had you saved the result here for 1 and 2, you would have used the same here. Okay, you don't have to calculate it again. That is the basic idea, friends. Okay, that is why this particular solution fails. Okay, that is why this particular solution fails. I'm adding a comment here, but the same code I will give you in the comment section. You can try it on your own and see. This is a small test case, but in a bigger test case, you will see that multiple sub problems are getting repeated. That is, you are again and again finding the solution to the same sub problem. Okay, that is the defect here. That's why this solution is facing time limit exceeded error. Okay, this first solution will face the time limit exceeded error. Okay, so how to improve it? See, just exact same thing. Just see here what we are doing here. Exact same thing, but what we have to do next thing is, after these two, I will see, I'm going to cache the result. That is, see, this minimum value I am written it currently, but in my next solution I will be caching this value. Okay, that is for each robo index and this factory index, I am going to cache this particular value, so that whenever the next time this particular things are called together, that is the robo index and factory index are the same that we have visited previously, I am simply going to return this value again. Okay, as simple as that. Okay, what I have to do after these two conditions, I have to add another value to check whether this segment we have seen previously or not. If we have seen previously, simply return the value of the same. Okay, don't do all this processing again. This processing I'm trying to avoid again. Okay, so this is going to be my optimized solution. Okay, this solution will be working. Okay, so what I'm doing it here, everything remains the same. Okay, this whole path remains the same. Only thing is I'm going to declare a DP array now. Okay, this is I'm declaring to cache the solutions. Okay, so initially all the values will be -1. Okay, all the values will be -1. Okay, so yeah, basically you have to see like what I'm doing. I'm declaring I'm first of all declaring array whose values are -1, and the length is going to be till the length of the factory length. Okay, then I'm again for all of these. Okay, for all of these I'm declaring another. I'm adding them to another array whose length is going to be the robot length. Okay, so what I have to do now? See, this is the additional path here. Yeah, these two will remain the same. This is the additional path here. Okay, return the results from cache if it exists. Okay, what I'm doing, if dp of robo index comma face index, that is factory index, is not equal to -1, that is, remember, -1 the default value, in that case return the cached value. Okay, initially the value will not be cached, right? So how the value I'm going to store the cache? See, if the value is not cached, this particular condition will not be true. Okay, so we are going to call all these regression steps here. Okay, after that we are going to that. See, now I have k1 value, now I have k2 value, now I have the distance covered. Okay, so now I'm going to cache it. Okay, dp of robo index comma this factory index is equal to min of this. Okay, previously we were returning it as it is, but now I will be caching it. Okay, I'm going to store it in this dp array. Okay, I'm going to store it in this dp array. Okay, then I'm going to return it from the dp. Okay, as simple as that. Previously we were returning it directly, this time I'm going to store it in my dp, and then I will be returning it. Okay, as simple as that. Okay, so next time whenever I reach here, okay, this from here itself I will return that value. Okay, I don't have to do the same calculations again and again. This calculation don't have to do again and again. Okay, these two steps I don't have to do again and again. Okay, that is the basic idea of this. Okay, if I run this and show you, this is how it looks basically. Yeah, both solutions are getting accepted, and I've already submitted the solution, and it accepts. Okay, this solution gets accepted. So this is one such solution. So what we learned here, see, ultimately what we're doing here is a kind of a brute force approach. Okay, but only thing is we have sorted the thing. Okay, we have both the arrays sorted, and we're trying brute force approach to see which solution gives us the minimum distance for the robots to travel. Okay, that solution we are going to take. Okay, and we tried without optimization, then we catch some of the results, because see, here you saw, right? If I can show you that again, here you saw, right? This 1 comma 2, this is again and again coming. Okay, though this is a smaller problem, still, okay, in this itself you can see there is a scope for optimization, right? So in the bigger problems, think of how much optimization can be done. Okay, that's why in the other solution we are optimizing this, and this solution gets accepted. Okay, so yeah, friend, this was all for today. I know, like, this question, I don't think it will be of any sense if you are preparing for initial level of interviews, because here, see, unless you know the trick, you will not be able to solve this kind of questions. Okay, yeah, brute force you can try, but yeah, if you want a solution to be accepted, I don't think without the tricks you will be able to do that. I accept that fact, because yeah, this is not a logical solution according to me, the way they have told it. They are proving those in the editorial. If you see, they have given some analysis, and then they are saying like, yeah, this particular thing you should be doing, yeah, analysis part, yeah, this particular part, what I'm saying, they have done this analysis, and then they are saying that you should be, always the first robot should be tied to the first factory and all that thing. Okay, so yeah, those things, only if it is given as an analysis, then we can accept that. Okay, but if you're solving this question for the first time, I don't think you will be knowing about all this analysis, right? So I don't think this will be a good solution to test candidates experience in programming or capacity in programming. According to me, this is not the right way to test that. But yeah, in this question we got to learn some of the things, like how to improve these solutions using the caching approach. We can cache the results. See, whenever you're doing this kind of function calls and all these things, certain function calls will always be repeating. So instead of repeating the calculation, we can cache the results and use them again and again. Okay, that is something that I felt I learned. Okay, and I want to teach you the same. Okay, so yeah, fun. That was all for today. Happy Diwali once again. With this, the October month solution is over now. We will meet tomorrow once again for the November daily code challenge. First day solution. Okay. See you tomorrow. Thanks a lot, and happy Diwali once again.